Let's take a look at an example of an asymmetric ether, an ether that has two different groups. In this case, propyl tert-butyl ether reacting with hydrobromic acid. See if you can draw first the product of the reaction and then try the mechanism. Now, the products that we'll get will be the result of cleaving the ether here at the oxygen to produce the two alkyl fragments, in this case, both connected to bromates. The mechanism by which this occurs starts with the oxygen picking up a hydrogen. First step of any reaction involving a strong acid, protonate the strong acid, or use the strong acid, that is, to protonate something. In this case, we're protonating the oxygen on the ether to make it a good leaving group. Now, what that means is it's going to leave one or the other of the carbons. And in the previous example, we saw that that happened as an Sn2 reaction because we could not get a viable carbocation. In this case, we actually can make a good carbocation, and since we are under conditions that favor carbocation formation, protic conditions, then we will form that carbocation. And the way that happens is by breaking the bond here between the tertiary carbon, and the oxygen. The oxygen, of course, will keep the electrons. And that gives us a carbocation. It also gives us our neutral alcohol as a leaving group. Notice that we have not yet used the bromide that was formed here in that first step. We can do that next, and of course what makes this an Sn1 reaction is the fact that Sn1 and E1, as we say, are unimolecular. A carbocation is formed. That gives us our first product, and it also gives us the alcohol resulting from the ether breaking off with the less substituted group, the one that would not form a carbocation well. The alcohol then goes on to react with an additional equivalent of HBr to produce the second product. I'll go through that mechanism here in just a minute, but if you can figure that out on your own, then you can skip the rest of this video. So if you are continuing to watch, you want to see the conclusion mechanism of this mechanism, which is the reaction of this primary alcohol with HBr to produce the corresponding alkyl halide. Now, this is, of course, an organic 1 mechanism, but let's go through it for practice. The first thing that we're going to do is use a lone pair on the oxygen to grab the hydrogen from the strong acid. This breaks the hydrogen-bromine bond and leaves the oxygen with a positive formal charge and an extra hydrogen. And why are we doing this again? We're making a good leaving group for the bromide to replace. Now, because this carbon, where the oxygen of the water, or the leaving group, is located, is primary, then we are using an Sn2 mechanism, which is, as we say, Sn2 and E2 are bimolecular. Everything happens at once. In this case, the everything happening at once is the nucleophile attaching and the leaving group leaving. So that gives us our water byproduct, which is the leaving group after it's left, and it gives us our alkyl bromide.